Welcome, everybody, to another Tuesday Livestream. This is Amy Williams here from Skellig. Now, today, what I figured we would talk about first is kind of MQTT and Sparkplug. That seems to be a pretty common question that people ask a lot, so we're going to attempt to get into it a little bit. The question was asked about specifically with like ignition and Sparkplug. But I feel like in order to understand Sparkplug, you first have to understand MQTT. So we're going to first take a look at that. So MQTT, hopefully everybody watching knows what that is. But for those who don't, it's a brokered PubSub message protocol. And it's kind of taken the OT side of manufacturing by storm. And the reason being is honestly, it's so easy. Almost anybody can pick it up, which is really nice. Like, are there other things that do PubSub? Sure, but they're a little more complicated. To prove the point, up here we have MQTT Explorer. If I want to connect to a free public broker, I can do that right now. I can just go to testmosquito.org, hit connect, and there I can see everything, right? Just as a quick refresher, the way it works is things in bold are your topics that anybody can publish to. And then below you have messages, which is the values. And those can kind of be whatever format you want. MQTT is super duper flexible. That makes it great. All right. So when MQTT was first kind of released into the world, everybody was excited. They started using it for a lot of different things. I think it might be BMW that actually also uses MQTT for some stuff. I'll have to check. But the industrial manufacturing world also ended up using MQTT. And they kind of noticed some things about it that could be improved, and that's kind of why we got to Sparkplug. But before we get into that, let's cover a little bit about how MQTT works, like I said. So it's nice and simple. You really have two parts. You have the broker, and then you have the client. So in this example, testmosquito.org is the broker. You don't really see that. It's just kind of running. But then you can view the data from something like a client, which is MQTT Explorer. Awesome. Oh, I'm in the way. There we go. Cool. Now, what we're seeing from Explorer is people like publishing messages and subscribing to them. It's pretty cool. Like every time something flashes, it's being published too. But that doesn't happen just by magic. No, there's actually like this whole mechanism happening in the background. And what's really happening is you have not necessarily messages. What are these things called? Mechanisms going. And there's kind of not that many, luckily. So for the broker, you have connect, pubac, pubrec, pubcomp, subac, unsubac, pingrisp. Basically, there's only about 14. Now, to keep track of that, I actually made like a little cheat sheet here, so we can kind of zoom in a little bit. But these are all of them. Again, let me zoom in. Again, I think there's only 14. It's not that crazy. So basically, when a client connects to the broker, they're going to send this little connect message. The broker is going to say, oh, I got it. It's going to send back the connect. And then when they publish, you kind of have this handshake going as well. So you can have different qualities of service to make sure your message gets there. So if it doesn't, it'll retry. All that jazz. Now, when we look at MQTT Explorer, I'm going to connect to just my local mosquito broker. Most people understand this part and they don't get hung up on it. But the hard thing about MQTT Explorer is I feel like it does a really good job of showing only the publishing and the subscribing, which is honestly like 90% of MQTT. But it doesn't quite show the granularity of how that connect message works. And I do kind of want to take a moment to talk about it because it's important when we think about Sparkplug. So something that the MQTT spec talks about is when you connect, you have, if I expand this out, this option to configure something called a will message. Also, keep alive time. So basically what that is, when a client connects to a broker, it can send over something that says, if I disconnect, publish this out. So that's amazing because now you get to have some kind of statefulness. Now, if you want to see how that works, we can actually watch that. You can watch all of these mechanisms with something called Wireshark, which is a free thing. You can download. It's a really helpful tool. I like it. So that's what we're going to open right now. So we have a thing called Wireshark. And we're going to filter here on, according to my little cheat sheet, a connect message is message type equals 1. And we're going to click enter. Okay, great. So I have my little MQTT Explorer here. And what I'm going to do is in the background, you guys don't have to see this, I'll just show it quickly. I have a Python script that's going to be the client that's just going to connect to the broker. And we're just going to see what that connect message looks like. So I'll put that back over there. We hit play. And it says connected. Awesome. So let's see if we can find back here our little connect command. We're going to disconnect and reconnect really quick. Just try that one more time. Control C. Localhost. Click play. Okay, great. So my little Python script, all it did was it connected to the broker and then it published a message and it said hello from the test client. That's lovely. Now maybe we can find the connect message back here or not. We'll see. Aha, yes. Okay. So what's cool is what we're looking at on Wireshark is that connect command coming from my client. And you see there's some stuff in here. In fact, we have the client ID and we have the will message configured. So what that means is I'm going to bring this over. I have my little Python script going. What I'm going to do is I'm going to stop it abruptly. Okay, it's going to be very angry at me for doing this. Let's see if it'll. Okay, there we go. And now you can see it published this message. Oh no, I died. And it has a little dead face. And the reason it did that is because I configured that will message when it connected to say that little string thing there. I'm pretty sure we can find this in the code. Here it is, right here, right? Just like that. Very simple. Awesome. Now, the other thing that you can do too in the connect, like I said, is the keep alive, which is another important thing when trying to keep like session awareness. And basically the keep alive is a time in seconds that your client and your broker, they're just going to ping each other to make sure they're still connected. And we can see that they're still doing that right now. I think that's message type 12. So we can go over here. We can look at 12. And we'll see that we have all of these ping requests going. And we're probably going to have some ping responses as well. Yep. So they're just talking to each other so they know they're still connected. So that's amazing. So that's why MQTT is so powerful, because it's super, super simple. And yet, even with this very simple and easy to use protocol, you can still keep track of who's connected to what, and with the quality of services, make sure messages actually get where they're going. Amazing. Now, the problem though is when you get into the manufacturing world, I think what people realize quickly is absolutely nobody left to their own devices does anything the exact same way. Like if I asked you to configure what should your will message be, there's like a 0% chance you're writing, oh no, I died, smiley face, right? You're probably going to put maybe the device info, the PLC number or something. I don't know. But the thing is, nobody did it the same. So that's kind of a problem, because understanding what is connected to your broker, what is creating, hopefully, like your process data, is a super, super important behavior and thing that needs to be aware of. And it wasn't very interoperable because everybody was doing it differently. So that was one major critique of the MQTT specification as it was. The second thing is this connect stuff is totally optional, right? Because with MQTT Explorer, we connect to things all day long, and there's no like will message in there because it'd be obnoxious, right? Like we always use this, typically I use it, right, as a diagnostic tool just to connect and disconnect. So that's another problem, because somebody could say, oh yeah, I'm doing MQTT on my PLC, but they also could have configured it wrong, and so it goes offline and nobody's any wiser. That's another problem. And then the third kind of big issue was, again, going back to interoperability, one of the powerful, it's a double-edged sword with MQTT. You can send literally anything. So again, for your process data, nobody was sending stuff the same format. Maybe people chose JSON. Maybe they just did regular text. There was nothing enforcing them to be standard. So it made it hard to kind of build on top of an MQTT infrastructure, at least for process control, because you didn't really know what was your data going to look like, right? Okay, so for all of those reasons, Eventually, they came out with something called Sparkplug. There was Sparkplug A, but nobody talks about that. But instead, there's Sparkplug B, which is pretty good. Now, Sparkplug B is a bit more complicated than regular MQTT. It's not just a client and a broker. People were thinking, you know, manufacturing, it's kind of similar. There's actually a lot of things that could be kind of grouped together. So we're going to add a few more definitions. And so we'll go to this picture here. So Sparkplug kind of said, all right, guys, we still have clients, we still got brokers, but we're going to add a bit more detail on what these things are called. So the first thing is we're assuming that in manufacturing, most stuff out there that makes data probably isn't natively publishing MQTT, right? Most likely it's connecting into something called a gateway. And that gateway is going to take your weird plant floor protocol, turn it into MQTT, and publish it off. So they kind of said, all right, we're going to add two definitions. We have something called a device, and now we're going to have something called an edge of network node. And in the manufacturing world, these are going to be the most popular things you have. In addition, we still have the broker, so that's great. But then we have something over here called the primary application. This one is a little confusing. So the reason that it's outlined in pink is because just a reason it's pink and our edge of network node have a pink outline is these two guys are friends. They're going to talk to each other. So basically the point of the primary application is to kind of help coordinate the statefulness of all of these edge of network nodes. Then there's another thing called your host application where it's basically mostly just going to be consuming data from the broker. And then the other thing that they did was they added in messages. So this isn't like mechanisms like with regular MQTT. These are actual messages you can see in the broker. And there aren't that many. There's end command, D command, birth, death for nodes and devices. So there's like 1, 2, 3, 4, 5. There's like 7 messages as well that they threw in there. Now, the question asked about ignition. Okay, I made a crazy picture to try and like summarize all this together to kind of show you what this might look like. So remember, your edge of network nodes are probably the most popular thing you have. So you're going to have a bunch of them. And you're probably going to have a bunch of devices with them. And so when they're making the spec, they were thinking, okay, knowing we have these categories of things, how can we easily get some standardization on the topic, standardization on the payload? And so they came up with this very, very rigid topic structure. So it's Sparkplug, well, we're using Sparkplug B. So it's Sparkplug B v1 / group ID / message type / edge node / device ID. Now, when we imagine that our plant looks like this and we're just trying to do plant floor control, this kind of makes sense, right? Because if I'm trying to figure out, like, okay, I have some process data, how do I find it? Well, first I'm going to go to my groups. In my groups, okay, then there's going to be just a bunch of edge gateways. Okay, so that's my edge node ID. That makes sense. And then I get to drill down just the device. So, like, when you see the whole picture, it kind of makes sense why they came up with this topic structure. Now, I know, hopefully you guys are really stoked about the UNS. You might think this sucks, because when I'm thinking about building my business semantic hierarchy, that topic structure isn't quite enough. And I agree, I'm with you, but we will save that to the end. Let's just focus for a minute on like what Sparkplug is, what it's trying to do, and how we can use it, right? Okay. So that kind of explained the groups, that kind of explained the standard topic structure. The other thing the Sparkplug spec did as well is it standardized what the payloads look like. It's pretty nice. It kind of looks like a JSON. So we're going to make some Sparkplug data with Ignition and try to understand how this all works. So here we go. Let's open up Ignition, our favorite app designer first. Okay. All right. Drag that over here. So we have our super gigantic Ignition designer open. Go to our view. All right, so what we have here, hopefully you guys can see it. What we have here is like the simplest ever drag and drop screen to try and understand a little bit how all of this Sparkplug stuff works in Ignition. So to start off, we're going to keep it super simple. I just made a folder with 2 memory tags called high limit, and the other one is called set point. So what we're going to do now is grab our gateway, and we're going to enable our MQTT transmitter and see what does ignition send out. My trial expired, so that's good. One sec. Set trial. Cool. All right. So, by the way, we should probably explain this really quick too. If you want to use MQTT with ignition, I think the easiest thing to do is to get the Cirrus Link modules. But just as a word of warning, they are Sparkplug, which again, as hopefully we will see, kind of makes a lot of sense for process control. What we're looking at here is there are 3. There's transmission, there's engine, and there's distributor. Distributor is basically their broker. It's actually pretty nice. It has some really good alarms and notifications right out of the box. That's great. But if you were to use something like HiveMQ, you wouldn't need the distributor. You could just connect instead to like that enterprise giant broker. The other things they have is they have transmission and they have engine. MQTT engine is what takes all of your Sparkplug messages and turns it into tags for you in Ignition, which is really nice. So if you have this set up, when you go to your tag browser, they will put in there for you this tag group called MQTT engine. And if you click it, it pre-populates all of these fun things, which is great. The other thing they have as well is MQTT transmission. Transmission is basically how you get data from your edge of network nodes to the broker, more or less. Okay. All right, so let's see if this thing is set up or not. I might have disabled it. Let's see. Transmitter. Let's look at our transmitter really quick. So if you're going to set one up, you can kind of call it whatever you want. Tag provider, for this example, like I showed before, we're going to use just the MQTT tag provider I made, and all that's in there is a little thing that calls temperature, high limit, and set point. Great. So that's the tag provider part. We can scroll on down, and we get to our Sparkplug settings. Now, remember the PowerPoint picture before. Hopefully by now we kind of understand what they're getting at here, right? The group is how do you logically group all of your edge nodes, which are usually all of your edge gateways on the plant floor. Then what do you call each unique edge node? And then beyond that, what do you call each device connected into your gateway? Just to keep it true to the Sparkplug specs, we understand what we're looking at. I'm calling things just group A, edge A, and device A. And we will see those, hopefully, in our topic structure when we publish. All right, so this is indeed enabled, so let's hit save. And, oh, nice, there we go. Okay, great. So, it's enabled. Ignition is publishing something, so let's take a look. Oh, it's because I disabled it before. That's why you have those. Okay, let me disconnect really quick. I don't want to get into those just yet, so we're going to reconnect in 1 sec. All right. I want you guys to see what happens when we connect, basically. That's all I want to do. So we are going to connect to our little broker. Amazing. So now what we're going to do is we're going to enable the transmitter, which means we're bringing our edge node, our edge gateway, basically online. All right. Click enable. Click save. And there we go. This is what I was looking for. So what do we see? We see 2 messages, end birth and debirth. Now, what is that? Well, we're going to go back to my little cheat sheet here in the background. So remember, Sparkplug still has all the same mechanisms as MQTT because it is built on MQTT. It just has some extra things with it, which are these fancy little messages. And so these are pretty simple things, not too many. Basically, what the Sparkplug spec does that's so critical is it forces these edge gateways to announce that they're online. So that's why you're always going to get these birth messages from your edge node, a birth message from your edge device. That's amazing because you can't forget it. If you're using Sparkplug, you know you're going to have these messages, you know you're going to have some sort of stateful monitoring. I think if we look in here as well, we should be able to see those in the connect. So let's look at our connect. I think that's message type equals 1. Let's see. 1. Oh man, there were a lot. Let's see if we can find one. Okay, so you can see that. You guys didn't see it because, again, these mechanisms you don't actually see in the broker, but what happened was Ignition did send that connect command, and in it, because Sparkplug mandated it, it filled out all of this will stuff, and it said, okay, listen, this is our will topic, and this is a standard topic, right? So that's wonderful, because if you're going to build a SCADA system or an MES system or like a historian, because these messages are standard, you can actually build applications to be like, okay, when I see a birth message, I kind of know this thing's online. Okay, when I see a death message, I could react accordingly, right? So that's amazing, because now we got some interoperability. We have some stateful awareness. All right, so with that, that kind of covers why we see this N birth and this D birth. And remember, the device we configured in the MQTT transmitter. That's why it says device A. That's why this says edge A. That's why this says group A. This was all configured in the transmitter. If you at your site wanted to do it differently and add, more context in those, you totally could. And I think a lot of people actually do go that route when they're trying to build a unified namespace. But to just keep it simple, that's why we said group A, edge A, device A. All right. Now, the other thing that kind of sucks, though, is, I don't know about you, this isn't exactly the most human-friendly thing in the world. I don't really like the boxes. I can't really understand this. And so what's happening here, you got these like funky little arrows. The Sparkplug spec says that you should use, well, it doesn't say, it forces you to encode things with Google, I think it's protobuf buffers. A key thing to note here, encoding and encryption are two different words that mean two different things. This is not encrypted. This doesn't mean that nobody can figure out what's here. It just means it took some data. I think it made it binary. I don't know. Someone can check me on that. But they just made it more efficient to transmit over the wire, and they made it not human friendly. Now, something that I like to do when trying to understand Sparkplug is kind of unencode this. And again, because this isn't encryption, it's just using like a pattern effectively that's out there on the internet. Anybody can unencode this. Now, what's amazing is thanks to like the internet, you don't even have to be like very savvy with protobufs to do this. There are lots of things on like GitHub that you can just download and they just work amazingly like right away to unencode these things. I'm pretty sure that's what I did here. Actually, no, it's a fun fact. Apparently, I think Walker mentioned in the UNS workshop that he made a version of MQTT Explorer that actually does unencode it, but it's like a beta. So I don't know. If we have time, I might go and try to find that and give it a go. I didn't realize that existed. I wish I knew, because then I would have used that instead of having to deal with downloading stuff. But that's okay. It was a good learning experience. Okie dokes. So what I have here is another nice little Python script. The code doesn't matter, but the point is, let me actually make this hopefully bigger. If I substitute, let me make this bigger. Okay. So what this script does is it's just going to unencode everything. So what we're going to do is reconnect and actually take a look at what those messages were. So we're going to come back over here. Sparkplug transmitter. Let's disable. Actually, we can watch it die as well. That's fun. All right, die. We got some death messages. Okay, great. So the other thing that the Sparkplug spec makes you do is when you go offline, you send these end death messages. And what's fun is we can actually look at them. And what are we seeing here? Well, we're seeing again that we have a standard topic and we have this standard payload structure. Again, it's all in the spec, which is again a free thing online you can go look up. But it's nice because you have, again, basically just standardization, which leads to like more interoperability. Okay, great. Now, the other thing that I wanted to do was see what does it look like when Ignition kind of sends a message and when we try to send a command back over MQTT. So let's take a look at that. So back to Ignition. Hopefully we're read and write We're online. What I have here is the literal, like, simplest screen ever. The way this was made was this ignition tag. I think I grabbed the set point, I just took it, and I dragged it onto the screen, and that was it. And then the same thing, I went to that MQTT engine, which comes from that module. Remember the Serious Link module, one of them is MQTT engine. And I went in here, I went to my edge nodes, my group, my edge, device, temperature, and I just grabbed this and dragged it over as well. And you know what's cool? They're like red, and we have a bad symbol, and that's because Ignition saw those end death messages and is like, oh god, they're offline, quick, let people know. And that's part of the Sparkplug spec as well, to let things know, like, if device is disconnected, I think you have to make some things say stale, but we can look into that more later if people are interested. Okay, so we're gonna put our transmitter back online. And what do we expect to see? Hopefully those birth messages, right? So we're online, we come here, we see we got birth messages, that's awesome. We can look at our little code and take a look at what those guys look like. So we can scroll back up and we see, yep, the first thing that happens is we get the N birth. And as part of the birth message, per the Sparkplug spec, what it's gonna do is actually publish like all the metrics. Same thing with the device. So it's publishing the temperature high limit and I guess, yeah, and the value. Let's see, temperature, high limit, yep. What else do we have? Oh, and here we go, and here's the temperature set point. Okay, whew. So that's just kind of par for the course to be efficient, because then when things change, you don't have to publish everything. You're gonna change only what changed. We will show that in a sec. All right, so those things are online. That's amazing. So what I wanna do now is we're gonna go to our edge device and we're gonna change a value, and we're gonna see what does that do. We're gonna change the set point to, I guess, 62. Well, if we come to our Explorer, it did that by doing a device data message. So I probably should have spent more time explaining these. Let's do that right now, actually. Sparkplug B. Okay, so Sparkplug doesn't add that many new things, but it does add these messages. So you have birth messages for when your stuff comes online. Then you have the data messages, and this is gonna be most of what you see, most of what you care about. This is like that process information, basically the data. Those are great. Then you have command messages and death messages. We already saw death messages. That's what happens when something gets disconnected, it goes offline. But then we have the commands. So this kind of goes back to why we have that primary host application. It is assumed in the Sparkplug spec that you're probably going to have something that is controlling all of these devices. And again, that's like your primary host. It's going to do that by sending these N commands or D commands. So if you want to send a command to a node, it's going to be through N command. If you want to send a command to a device, it's going to be through D command. So hopefully what we saw was our device, which was our ignition tag, it just gave a new value because it changed. We saw it publish that through a D data, here it is, through a D data message to the broker that then we can view through the engine, right? Because we saw that the 62 up here also updated. Now, what's going to happen though if I try to write to my device through MQTT? So the way I'm going to do that is we're going to go to MQTT engine. We're going to expand out edge nodes, device, temperature. We're going to write to the set point. We're going to say, actually, I want your set point to be 77 because that's a better number. And we click enter. Now we have that D command message. But also, you probably didn't catch it because it was fast, we got a D data message back. So we can actually look at that by going back to our little Python script here. We can scroll up. So if we scroll down, what do we see? Message received on. We have our D data. Okay, so here we go. So first thing, and this order is important, the first thing that happened was we had that D command to say 77. So our, the way you can think of it, ignition is acting as the primary host application. So it's sending that D command down to our device. Our device got the command, changed its value, and because the value changed, it then published it back to the broker. So let's reiterate that again. So we see that when we try to write over Sparkplug, we send a D command, it's 77, that's great. It made it to our device, so then our device published back, hey, here's my D data. And this is also really interesting. Oh, come back here. It published back only temperature/set point. It didn't publish everything because remember, we have two values here. We have the set point and the high limit. So what's really great is the Sparkplug spec is doing report by exception. And that's something I probably should have mentioned before. MQTT, you could do report by exception if you're smart about configuring like on change, do publish, but it does not inherently do it. There's nothing in the spec that really encourages it because of the fact that you could not configure that statefulness. But the Sparkplug spec, it did all this hard work setting up these birth messages, setting up the death messages so you know things are connected, that it actually says in the Sparkplug spec, you should do report by exception. And in my opinion, any gateway that's actually worth its money is just going to do report by exception. That's amazing. But also, just as a caveat, if you're like me and for funsies, you're like, hey, I want to publish some Sparkplug messages by hand by like writing a code or something. The spec does not like force you. If you're using something like Python or if you're just using like Node-RED and you want to test, you can do not report by exception, but like that's not ideal. I wouldn't recommend that. Basically, if you're going to use Ignition, you can assume most of the time it is going to be report by exception because that is what the Sparkplug spec is all kind of about. It's much more efficient. Okay, great. So what else did I want to show? So if we come back to Ignition. Yeah, so I think that was pretty much hopefully everything. I think we covered all of our messages. We saw things come online. We saw that they sent data. We saw that when we wanted to write to something over Sparkplug, it did it through these command messages. And we saw that when we disabled the transmitter and it died, everything sent out those D deaths. And we saw Ignition turn red because it knew, okay, stuff's offline, react accordingly. Okay, cool. So that was my very long explanation of Sparkplug versus MQTT. I hope that made sense. Thank you guys so much for watching. I really appreciate it. I know the Sparkplug spec probably isn't the most invigorating content, but hopefully it was helpful to somebody someday. So thank you guys so much. I hope you guys have a good week and talk to you next time. Bye-bye.